So for my presentation problem, I had question 9, which states that Ben is trying to outgift his wife Leslie. He knows that Leslie loves handmade gifts, so he is going to craft a box out of cardboard and fill it with waffles. Leslie loves waffles, so he wants to make the volume of the box as large as possible. He starts with a piece of cardboard measuring 8 by 8 inches and builds the box by cutting out the corners so the box has sides of equal height and no lid. What are the final dimensions of the box? Round to 1 decimal place if needed. So this was kind of like that play pause it video we had to view before class on Tuesday. So I'm going to do what he did and make the box 2-dimensional, even though it's supposed to be 3-dimensional. So I could show the cuts, and they're not all they might kind of look a little sloppy just because I'm using my finger to draw this. So we label all sides X, and then we know it's an 8 by 8 box, so it's a perfect square and there's no lid. So for the length, we would do 2x minus 8. I'm sorry. Just because you see the 2 x's right here and right here, and then it's 8 inches. Same for this one. So this is the length. The width is going to be the same thing. 2x, x right here, minus 8. Oops. Okay. And then we're trying to figure out the height to get the maximum volume. Oops. So h equals x. So then we plug that into our volume formula, which is length times width times height. So I'm going to kind of do that down here. So you have 2x minus 8 squared, since that's both the length and width, times x. This is the volume. Okay. So once we solve that, we just FOIL. So I use the FOIL method. And I got 4x cubed minus 32x plus, 32x squared plus 64x. So we have to remember that the critical numbers will lead to the maximum volume. So now the next step is to find the derivative. And that would be 12x squared minus 64x plus 64. So then we set it equal to 0. And we solve for zeros. So zeros of the derivative correspond to critical numbers, which might be locations of the local maxima or minima. So we were trying to find the maxima. So the critical numbers might be locations, but that doesn't guarantee that it will be. So once we solve for the zeros, so I'm just going to set the equation again equal to 0. Sorry if it's a little sloppy. You get x equals 4/3 or 4. There you go. So then kind of what the student on the video said, you kind of have to rule out what won't be the maximum we're using. So say we used 4. And we put 4 right here and 4 right here, and we cut out 4 inches of the paper. Well, that's going to take the whole thing, since obviously 4 by 4 is 8. So that wouldn't work. So we have to use 4/3. So x equals 4/3 or 1.25 is our maximum volume. Okay, so then you have to plug it back into the original equation. And when you do that, you get 4. So our original equation is this. So I'll just label it OG. So 4, and then you just plug in 4/3 to the 3rd power minus 32 4/3 squared plus 64 times 4/3. Okay, so then you get, so once you solve that equation, you get 1024 over 27, which is approximately 37.925. But the question states to round it to, round 1 decimal place. So then you get 37.9 inches cubed. And that's, go back to the original equation, and you can say that the final dimensions of the box is going to be, length is 1/8, width is 1/8, height is 4/3. So I guess 8 by 8 by 4/3 is the dimension of the box.